Hi everybody, this is going to be a video tutorial on how to do a chi-square goodness of fit test in SPSS. Now we don't actually have tutorial data in our classes for a goodness of fit test, so what I'm going to do today is focus on the example that was given in the lecture. If we look at the lecture notes, we see that we've got this example with distribution of blood types, and we've got 4 different blood types: A, B, AB, and O. One key thing to realize is when you've been given a ratio, often that corresponds to a goodness of fit test. If you remember from lectures, a homogeneity test and goodness of fit test are fairly similar. The only difference is that the expected value for homogeneity tests are all the same, whereas the expected value for a goodness of fit test can vary. So here we have distribution of blood types, and we've done a random sampling of 150 people in Toorak, and Toorak's just a suburb in Victoria, here in Melbourne. And so we've been given this data: the type A, B, AB, O, and the frequency data, 37, 28, 2, and 83. Immediately what I'm going to do first is pop this into a clean sheet in SPSS. So in the first column, I'm going to say that's going to be my blood type column. And I'm going to just give blood type A a value of 1, blood type B a value of 2, blood type AB a value of 3, and blood type O a value of 4. Now I'm going to change this in my variable view, and we're going to call this blood type. While it is numeric, our measure is going to be on a nominal scale. Okay, and so that pops up as blood type in our first column. In the second column, these are going to be our observed frequencies. Now, observed frequencies are simply the frequency that we get in the initial table, 37, 28, 2, and 83. So I'm going to put 28 here. Sorry, I've done that wrong. 37 here, and then 28, then 2, and then 83. And this is going to be my observed frequency. Now the word frequency or the word value, they can be used interchangeably when we talk about chi-squared tests. That's going to be numeric, and that's going to be a scale. Now what I'm going to do here is just to be a bit more certain with identifying the blood types and their values. I'm going to say 1 is blood type A, 2 is blood type B, 3 is blood type AB, and 4 is blood type 0, or O, I should say. Okay, so that's got a bit more certainty with their labeling now. Now, the last column that we need to fill out is the expected frequency, and this is something that we actually have to calculate. So if you, so looking at my lecture here, we've got a formula that we can use to calculate the expected value, and that formula is the sample size. So remember, the sample size is 150 in this example, so 150 multiplied by the ratio of each blood type divided by the total of the ratios. So to work out the total of the ratios, we're simply adding each of these values. So 10 plus 4, which makes 14, 14 plus 1, which is 15, and 15 plus 15, which is 30. So our total of ratios is going to be 30. The ratio here corresponds to whichever blood type. So the 10 is going to be blood type A, the 4 is blood type B, the 1 is blood type AB, and 15 is blood type O. So when we calculate the expected value, we simply do the sample size multiplied by the ratio divided by the total of ratios. And here, in this case, we have 50 as our expected value for type A. For type B, we get 20, and for type AB, we get 5, and type O, we get 75. So let's pop that in to SPSS as well. 50, 25, 75. And we're going to give this a name, and that's going to be expected. And that's also going to be measured on scale. Now that we've done that, we have all the data we need to put it into SPSS and to allow SPSS to do our calculations for us in finding the calculated chi-square values. So what I'll do is I'll expand this out. When doing a goodness of fit test, we need to first select data and weight our cases. We then choose observed because we want to weight the cases by the observed frequencies. Okay. Click OK. And that has been done. We then go to Analyze, Non-Parametric Tests, Legacy Dialogues, and because we are doing a chi-square goodness of fit test, we would select chi-square. Our test variable list is going to be our categorical variable, and that's our blood type. Our values here, expected values, are our expected frequencies, and they're going to be 50, 20, 5, and 75. And then we click OK, SPSS will spit out the output of this chi-square goodness of fit test. There you have it. So in this first table, you can see we've got the observed frequencies and the total sample size. We've also got the expected frequencies, which we calculated by hand, and we've put into SPSS. And then we've got a third column, which is residual. Now, residual is simply the difference between the observed frequencies and the expected frequencies. Moving down, we see that we've got SPSS has given us a calculated value for chi-square, 9.233. We would then compare this to a critical chi-square value, and that would tell us if we reject or accept the null hypothesis. But if we look down to asim-sig, this gives us our p-value. So we've got 0.026, which is less than an alpha of 0.05. In saying that, we have to reject our null hypothesis. If we reject our null hypothesis, we're actually saying that there is a difference between the observed frequencies and the expected value. Another thing that we need to take into account is the degrees of freedom. And our degrees of freedom in this case is 3. So that is a quick tutorial on how to do a goodness of fit test in SPSS. I'm hoping that will help you in completing your assignments for biostats.